You ever look up at the night sky and just get this feeling that we're missing something huge? Like something fundamental about how reality even works? Well, today we're going to dive into a really fascinating framework from a researcher named Devanand Yadav. It's a fresh take that might just hold the key to some of the universe's biggest mysteries. Let's see where it takes us.
And man, was Einstein right. Science isn't just about the answers we have. It's about the thrill of chasing the questions we don't. And right now, the biggest question in all of physics, the real head-scratcher, is what in the world is most of the universe actually made of?
Okay, so take a look at this. Everything we see, everything we've ever touched or measured, every star, every planet, you, me, this screen, all of it is just 5% of the universe. That's it. The other 95% is a complete mystery, split between this stuff we call dark matter and an even weirder force called dark energy. This is the question. I mean, this is what keeps cosmologists staring at their blackboards all night. It's the engine driving so much of modern physics, and it's the puzzle we're going to try and crack today using this really cool new dimensional idea.
Now, before we get to the new idea, we really have to understand the problem we're trying to solve. Realizing we were missing almost everything, well, that discovery took decades to unfold.
It really kicked off back in the 1930s. An astronomer named Fritz Zwicky saw that galaxies were spinning so fast they should have just flown apart. Something invisible, some Dunkel Monterrier or dark matter, had to be holding them together. Then in the 70s, Vera Rubin delivered the knockout punch with evidence that was just undeniable. And just as we were kind of getting used to that, bam! In 1998, we found out the expansion of the universe is actually speeding up, pushed along by something we now call dark energy.
For a long, long time, the best bet for dark matter was this idea of exotic particles called WIMPs. The theory was that they're all around us, like a ghost, but they barely interact with anything. So we built these incredibly sensitive detectors, buried them deep underground to block out noise, and we've been listening for decades. And the result after all that? A big fat nothing. Zero. Billions of dollars spent and not a shred of evidence.
And you know what? The dark energy problem is somehow even worse. When we use our best theories, like quantum mechanics, to try and calculate how strong it should be, the answer we get is wrong by this number. That's a 1 with 120 zeros after it. It's so wrong, it's been called the worst prediction in the history of physics. And when your best science is that far off, it's a pretty big sign that you're not just missing a detail, you might be missing the whole picture.
So this is where this new framework comes in and asks a really simple but profound question. What if the reason we can't find dark matter and dark energy is because we've been looking for them in the wrong place, or rather, in the wrong dimension? To really wrap your head around this, let's do a little thought experiment. Imagine a totally flat 2D world, like a piece of paper. The beings there are just shapes. What would one of those 2D beings see if a 3D object, like a regular old sphere, passed right through their world?
Well, from their perspective, it would look like straight-up magic. Out of nowhere, a single point would just appear. Then that point would grow into a circle, get bigger and bigger, then start to shrink back down, become a point again, and poof, it would vanish. It would completely defy all the laws of their 2D physics.
But for us, watching from our 3D viewpoint, we know exactly what's happening. It's not magic at all. It's just the cross-section of a simple sphere moving through their plane. It's a perfect example of how a simple reality can look incredibly mysterious if your perspective is limited.
So, here's the kicker. What if we are the flatlanders? What if the weird, mysterious things we see in the cosmos, like dark matter, aren't weird at all? What if they're just the shadows, the gravitational footprints of perfectly normal things happening in a higher dimension that we just can't see?
Now, this isn't just a random shot in the dark. This framework is built on a single, incredibly elegant rule, a pattern that, if it's true, could define the entire structure of, well, everything. Let's break it down.
So think about our experience right now. We can move freely in 3 dimensions of space, right? Up, down, left to right, forward, back. We control that, but we are completely trapped by the 4th dimension, time. It just moves forward and we're stuck along for the ride. This framework says that's not special. It's a pattern that just keeps repeating. A 4D being would be able to move through our time like we move through space, but they'd be constrained by a 5th dimension, and a 5D being would be constrained by a 6th, and on forever. This is what's called the recursive principle. It's a fancy term for a really simple idea. Reality is built like a fractal. The rules that govern the relationship between our 3D world and the 4th dimension are the exact same rules that govern the 4th and the 5th,
and the fifth and the sixth, and so on to infinity. That unstoppable flow of time that we feel, that's just what the next uncontrollable dimension feels like from one level down.
Okay, so really cool idea, right? An infinite repeating reality. But how does that help us with that pesky 95% of the universe we can't see? Well, this framework gives a fascinating and elegant answer to the dark matter problem.
And here it is. This is the big shift in thinking. The standard theory tries to solve the problem by inventing a new what, some exotic particle. This framework says, forget that. Dark matter isn't a new what, it's a new where. It suggests that dark matter is just ordinary matter. You know, atoms, protons, electrons, the same stuff we're made of, but it's existing in a higher, fifth dimension.
And honestly, the explanatory power here is pretty incredible. First, of course, we can't see it or touch it. It's literally not in our space. But we can feel its gravity because gravity isn't stuck in one dimension. It's the bending of space-time itself, and that ripple effect spreads across all dimensions. This idea also seems to naturally solve some other nagging astronomical puzzles. And, most importantly, it gives us a perfect reason why all those expensive dark matter detectors have found nothing. They've been searching in our 3D basement while the party is happening on the floor above. So this isn't just a potential solution to a physics problem. It's a complete reframing of what reality even is. It suggests the universe isn't just big, it's infinitely deep.
This table kind of lays it all out. Here we are, 3D beings. We have total freedom in space, but we're prisoners of time. A being one level up, a 4D being, would see our entire timeline, from birth to death, all at once, like we see a line on a page. But they'd be prisoners of their own version of time, a fifth dimension. Each level up gains a new freedom, but gets a new constraint. Our reality is just one step on a staircase that goes on forever.
And you know what the most beautiful part of this idea is? It means that science will never be finished. There's no final theory to discover. The universe isn't some finite puzzle that we can one day solve and put back in the box. Instead, it's an infinite frontier. Every time we answer a big question, like what is dark matter, we're just opening a door to the next level, with a whole new set of mysteries to explore.
And that's the thought I want to leave you with today. What if the whole point isn't to find the final answer, but to just keep asking bigger and more profound questions, forever? This framework paints a picture of a universe that is so much weirder, so much deeper, and infinitely more interesting than we ever dared to imagine.